Hello, and welcome to the 11 o'clock session. We are going to be having three speakers today in this session talking about challenges in internet and ATSC3 streaming. If you want to learn about content-aware encoding, that's going to get discussed. We're going to talk about time. There's always time for time. And there's some wonderful content in these three sessions from very distinguished speakers. The first one up is Thierry Fautier from Harmonic, and let me read Thierry's bio here. He is the current president of the Ultra HD Forum, the global organization responsible for promoting market adoption of UHD. As vice president of video strategy at Harmonic, Thierry is in charge of defining and driving the execution of long-term strategy of Harmonic's video business. Thierry is also co-chair of the MPEG Roadmap Committee that is tasked to present the 2020 MPEG Roadmap to the industry. And with that, I invite Thierry to please come on up. Please hold your questions to the end of Thierry's talk. We will have time for them, I guarantee it.
Thank you, Glenn, and hi, everyone. Sorry, I'm coming back. I was talking yesterday, so this time it's going to be a bit different topic, OTT, and one of the subjects in our industry is to know how we can scale OTT, and the second question is how can we bring the quality of experience as close as possible to broadcast. So this is the plan. So we'll look at some introduction and definition. Then I will give you a guided tour on what is content-aware encoding. Then we'll talk about latency. You have seen recent news, Apple supporting eventually low latency. Then I will give you some ideas of what is happening in the industry with the network optimization. And then we'll have a quick but very useful tour to what Netflix is doing, and then some conclusion. So first, we are looking at how OTT can scale. And as you know, broadcast has been for the last 25 years the reference. When I say broadcast, I'm talking about digital television with service provider or terrestrial networks, and now moving to a more advanced architecture with ATSC3. But in terms of streaming, I would say, and I hope you guys will agree with me, Netflix is the reference today. And we are going to keep that in mind because towards the end, you will see the comparison with what Netflix is doing. So the question is there a way live OTT can match those experience, broadcast on one hand, Netflix on the other hand? So one important caveat, because I only got 30 minutes, so I'm not going to touch other topics such as open caching, which is part of the Streaming Video Alliance, peer-to-peer, multicast ABR, eMBMS, which are other techniques also aimed at enabling the scalability of live OTT services. So let's start with some definition, and we need to have a very clear understanding. When we talk OTT, is actually there are two different kinds of OTT. There's the OTT best effort, such as Netflix, and there is the ABR delivery across managed network, which is a very different solution. So let's look at OTT best effort, consumer-owned device, and the device is either managed by an operator or directly by the consumer that we call bring-own device. Managed ABR is a dedicated VLAN, operator managed. Very often, the gateway is connected in a wired way to the device, and then the device is most of the time owned by the operator. So in terms of topology, you have a headend that can go to a managed network, to an operator set-top box, and that's what we call managed ABR. And you see the same headend can also deliver across the public internet, either to an operator set-top box or to a pure OTT device, which is managed by the consumer. And you'll see we'll have a different level of quality of experience depending on the type of network architecture. So let's look at the OTT. So OTT, you have the ABR headend with content-aware encoding. For those who don't know, content-aware encoding is a technology being developed initially for VOD by Netflix, but after that used for live, which is basically helping you to have the best quality at a given time, having more bandwidth used if the content is more complex and less bandwidth used if the content is less complex. Then the origin server is going to take the live feed, package it, and of course have the graceful degradation. If the traffic is too large, then you'll get to lower profile. CDN is, of course, unmanaged network. So this is best effort delivery, gateway, unmanaged also. Then two different type of boxes, operator set-top box or bring your own device, and very often Wi-Fi connection with an uncontrolled environment, which means you see a lot of side effects on the home network, which is something which is, of course, creating some of the challenges. So let's look at what we call IPTV 2.0. It's basically an ABR headend with sometime, unfortunately, CBR type of delivery, an origin server, a managed CDN managed by the ISP, a gateway which has a guaranteed quality of service, and a set-top box wired connection to the gateway. And in that case, if you remember the diagram where I compare those two architectures, my headend going to a managed network or my headend going to an unmanaged network, what we discovered is that the difference between those two architectures can bring a 300% KPI difference between unmanaged and managed delivery. So when you talk OTT, ask yourself, is it my own network or is it an OTT network? Very, very different performance for the consumer. So let's look where the quality of experience will be applied. So first, as you know, compression is the largest factor that will impact the quality of experience, because if your bit rate is too high or if your compression is too poor, you will have problem on the end device. Second is the packaging / origin, where you are packaging in a different way with different parameters, dash or HLF. Then comes the CDN, which has basically the role to span all the traffic across millions of concurrent sessions. Then you have the device with its own implementation of the ABR technique. And then you have the analytics, which is going to report back the performance of the player and help into the CDN switching. So these are CDN switching technology. So as you can see, the quality of experience is spread across different blocks and different functionality inside a ABR delivery. So content-aware encoding, I'm not going to go too much because you have seen last year, the year before, companies presenting results of those techniques. And here I wanted to share with you on the left the rebuffering. So we have tested CBR in blue and in green, CBR in green and our IQ content-aware encoding. And you see that on a 4G mobile network, we were able to reduce by a factor 3 the buffering ratio using content-aware encoding. The quality profile, if you use the CBR encoding, you see the bitrate is going to be too high, and therefore you are going to have problem in the network, and the client is going to pick only the lowest resolution. While if you have content-aware encoding, you can bring the bitrate down, so you can therefore enable HD, which is one of the holy grail in mobile networks. Startup time, we didn't see much difference. Oscillation of profile, you see that if you don't have a good compression mechanism, you are going to oscillate a lot, and this is, of course, something you want to avoid. So the takeaway is this type of technique can bring the bitrate by 50% compared to the classical CBR approach. This is something which has been already backed by Apple in iOS 11 2 years ago, and we're quite happy to see that being used for live, of course. And Ultra HD Forum has spent a lot of time to specify and to define this type of technique so that it can also be applied, for example, on UHD. Let's talk about low latency. So you all have heard about this problem of during the World Cup, people are watching the game and discovering that they have the result 30, 40, even 60 seconds behind the broadcast. And the reason is quite simple. You have an encoder which has a segment of, let's say, 6 seconds. You have the transmission to the origin server. You have the buffer of the player who is using multiple segments per the HLS or even dash specification. At the end of the day, you end up with a very inefficient way to deliver the content. If you look at what CMAF Dash has done, is basically to chunk the content on micro segment of 200 milliseconds, and the transaction is done on this basis. You don't have to wait 6 seconds, you have to wait 200 seconds. And if you look at the end-to-end delivery delay between the classical approach and the CMAF, you are going to see a huge difference in terms of performance. And of course, MPEG, as you know, is a standard. It's cacheable because it's HTTP on all CDN. You can expect this to be deployed at scale. So this is the results we have done of the trials we have done 1 year ago, based at that time on the state-of-the-art of player technology, so the encoding packaging provided by Harmonic. So we had on-premise unmanaged network with a CDN, wired or wireless connection. So we went from 5.5 seconds in the best case. And then when we go to the public cloud, also public CDN, we ended up to 9.5 seconds, which means that you can't talk about latency in the big case. You need to look at what is the network, what is the infrastructure, and also what is the type of client, because at the end of the day, the client also needs to deliver a very sustained performance. So basically, we are between 6 and 9x improvement versus what you have today in the deployed ABR system. So let's go back to my diagram about the quality of experience. So I have my compression, my packaging, my CDN, my network, and my client. So the good news is we have all those elements. The client gives you analytics. The network gives you analytics. The streaming CDN is going to give you streaming analytics. And you can aggregate all those information into what we call analytics database. And you have wonderful dashboard that is going to report all the problem you have in your network and generate a beautiful log file. And what we used to call that is a log file to nowhere, meaning you can't do much because those information are not useful to fix the problem in your network. So how do we move from there? First, what mobile operators have been doing is the way to fix that problem is basically to cap the traffic in what we call zero rating. So zero rating is you have all the different OTT service providers who have a commercial agreement with the mobile network operator. The mobile network operator is basically going to do a deep packet inspection and therefore is going to cap the traffic, let's say, 1.5 megabit resolution, which is about the standard definition resolution. And this is what you are going to consume with unlimited on your data plan. So it's great because the content provider is happy. More people are spending time on this application. You basically double your consumption with this scheme. And the operator is very happy because he's lowering his traffic. The problem of this approach is that you bring the quality at a very low level. But if you use some content-aware encoding technique, you can bring the HD content at the SD resolution. So there is also hope here to bring a much better experience than what you would do with the classical approach. So here you see zero rating, very popular in the US, but very disappointing in terms of consumer experience. And here, Glenn, you see I've removed some of my previous comments. You have the map of all the different countries, which is basically traced by an organization called OpenSignal, and is giving you what is the quality of experience of video, what is the video quality of experience on mobile network in each country. You see, as expected, you have some interesting countries, Czech Republic, Hungary, Norway, Emirates, Singapore, very high, and United States is close to Costa Rica, Indonesia, and Thailand. Why? But just explain to you, if you cap the traffic, that's what you get as a result. So you are here. So how can we move the bar from very high traffic at low quality to very high traffic at high quality? So first, what we believe is that the MNO can have his own service because it can control end-to-end the delivery, and it can deliver that on the internet, and have a network traffic measurement that will inform the OTT provider or his own service about the status of the network. And in that case, you can have a much more dynamic way to control the traffic. It's not a static way. Depending on the RAN, you can have a better way to provide more traffic, less traffic, and it's, of course, HD is the goal. You want to have more HD channel. You don't, of course, increase the CapEx. And here, you are going to lower the traffic because you are going to statistically modulate the profile depending on the network capacity. So if we take my diagram of before, and if I say, OK, I'm able to monitor all those different element client network CDN, I'm putting that into a database system. I have a dashboard, which is going to communicate to a network operation and policies for the control and also the data coming in analytics. And if I can, in real time, every 2, 4, 6 seconds, manage all this information and feedback to the CDN, to the packager, or to the compression, then I will be able to modulate the traffic. And this, of course, makes all the more sense when you have network congested. When the network is not congested, you probably don't need that. Everything, as we say, ABR auto-regulates. It's a bit like the financial market auto-regulating, but we know when the financial market is under stress, we need to have a very strong way to control the flow of money or the flow of data. And here, this is exactly what we're trying to achieve. So people are asking me, when can I buy that? I say, first, we need to agree on all the different specifications, the analytics information, the way you feed this back to the network. But we believe this is going to be a very important aspect for quality of service, and especially if we want to beat existing OTT service, such as Netflix. So if I look at my zero rating story, I have all those OTT providers who are basically giving you all the different services. And then going to the mobile network, you have mobile network operator who is going to look at the traffic, monitor his RAN, talking to different net device, and then in real time is going to feed some of the network information to the content provider, who is going to do probably a client-based decision on this RAN. I have to reduce the profiles because I cannot consume as much data as I want. So this, you see here, it's much more collaborative approach. The mobile network operator are going to report information via OpenAPI, and you know in the 5G network, it is now possible to have access to the RAN status, which was not the case in 4G. You can have a mobile network decision or client decision. It's open. You can have both. And there is also room for standardization in the MEC group of HC. They are trying to address that, and I hope Streaming Video Alliance is one of the groups who could participate to this activity. So here you see it's a more complex way to do network optimization. It's a fully dynamic API-based with monitoring information flowing to the network. And we hope this is something that can be implemented in the future. So let's look now at the Netflix case. So Netflix, as you know, 2015, December, they published a paper about per title encoding, how they define the profile for the different content they encode. Then they move to what we call a per segment encoding or per scene encoding, where this is what we are doing today in live, how to change the profile in real time based on the content complexity. So Netflix has that. Origin server, classical approach. CDN, they didn't trust the CDN companies. They build their own CDN in what we call Open Connect, and the specification is available. So that's a good quality of service. Gateway, obviously, they cannot control it because consumers have their own gateway or use the mobile network, and bring your own device, very often connected to the Wi-Fi. And we think with all the infrastructure Netflix has built on the per title encoding, on the CDN, and the client technology, they have the best OTT experience out there. I know there will be new services to come. There will be the Disney service. There's the HBO Max service. There will be the NBC service. So we'll see how those services will perform. But obviously, do not forget, I think in US, Netflix has more than 60 million consumers. So it's a lot of concurrency. So we'll have to wait until those new services come, of course, up to speed to measure the performance versus Netflix. So here I've put in a comparison table all the different technology you have to look at when you build a service. So you have content-aware encoding, the codec, CMAF low latency, the deep caching, the CDN switching, traffic prioritization, client acceleration, and network optimization. And you see some are related to encoding, some are related to packaging, client, CDN. And you see the first column is what most of the OTT services are doing today. And if you see from this table, we are far from the base. Second column is what Netflix is doing today with the public information. And you can see Netflix has already done a lot. And the third one is the aspiration roadmap you should all look at where you tick most of the box. And as you can see from what we do today, we are behind compared to what Netflix is doing and what we can do in the future using techniques such as content-aware encoding, low latency, and network optimization technique. I believe we can deliver something which is more attractive than Netflix. Of course, Netflix is not live, but the consumer doesn't care it's live or not live. When he switches box, if it doesn't work, he'll switch off to another service. So to conclude, OTT is still in infancy with regard to quality of experience. There's a big difference between unmanaged and managed network. Quality of experience is improved today with content-aware encoding and CMAF low latency. Network optimization, we believe, is going to be an important topic, and that's why we call it the Holy Grail, meaning we might have discovered that it's not that easy to implement. Of course, there are more traffic optimization techniques like open caching, peer-to-peer, multicast ABR, EMBMS. And we think that those are industry-wide problems. I'm quite happy that we are a member of the Streaming Video Alliance, and I think Glenn is also part of the member of the board. It is a good place to discuss all those topics. If you guys are interested, we have a meeting, a very nice place in Portugal in 2 weeks. But I'm also interested to get your feedback, so I assume I will have questions. Thank you very much.
So are there any questions for Thierry from the audience?
So for network optimization, are you looking at jitter, traceroute? What type of tests are you looking at?
So basically, you saw in one of my slides, so the analytics we collect today are a good start. So for example, this one. So buffering, how much rebuffering you get, what is your startup time, the profile you are decoding. So that's more for the quality of experience. Now, at the networking level, you can, yes, access to a lot of information, such as all the one you mentioned. So there are different levels. There's the quality of experience metrics, but also the network metrics. And one of the challenges, to be very honest with you, is where do you get your analytics? On the client, on the CDN, on the network?
D, all the above.
But we can't boil the ocean, right? We have to pick. So to start, for example, an easy way to start is client. But the client doesn't always get access to the networking information. So for example, you have analytics company who send you a small SDK that you put in your client, but this is not as powerful as the true client implementation where you have access to all the networking information, all the different routes you got. And of course, there are other elements like CDN switching. You might switch to different CDNs, so you are in different environments. So this analytics information that I put here, all the big machine, this one I think is going to be an interesting case to take all the information and to be able to, in real time, to make the right decision.
Right. I mean, I think it's better for the client because if you're jumping between Wi-Fi and mobile, and now you're in a car, and now you're jumping between different POPs, that's going to be very dynamic.
Yeah. But yes, a lot of work ahead. Thank you for the question.
Do we have any other questions from the audience? If not, I'm going to throw a little bit. Thierry, I kind of picked up in your talk here that this isn't a one person solves all those problems. So where do we go from here? How do we pull it all together? What's the next steps?
Well, if you look at this diagram, you can see that there are multiple elements in the ecosystem that needs to be involved. First, you have the analytics collection. And then what are the decisions you want to make that will impact compression, packaging, and CDN? So you need to have at least a good flow of information from all the devices in the network to go back to the network and then to inform the device what to do. So my take is we need to agree on APIs, protocols, and then let each company cook their own network optimization strategy. And I think, as I mentioned, Streaming Video Alliance, for me, is the place to put the problem on the table and try to solve collectively all those problems. I do not think any company can solve that except a Netflix, which is vertically integrated from the production to the distribution to the caching to the client. In that case, yes, you can do it.
May I suggest a topic for next year?
Yes.
Come back and tell us how we've done in the past 12 months.
Yes.
And where we need to go in the next 12 months.
Yes.
I think this is an interesting topic space. And it's something that we all need to work on together.
I hope I could open some eyes. And if we have volunteers, I will forward them to you to get the Streaming Video Alliance membership, maybe. Just kidding.
An applause up for our speaker, please. Thank you, Thierry.